All right, good morning and happy Tuesday. It is 5:53 in the AM, and I am planning to do LeetCode bi-weekly contest 96 from last Saturday. Let me share my screen. Okay, here we go. And it is time to shine. Okay, bi-weekly contest 96. Here we go. Open these guys up. Value. Okay. Minimum value they have in common. Scene is the set of A. B dot sort for X in B. If X in scene, return X. Uh-oh. Today, what is this? None. Oh, what if there's none in common? Returning it one. Oops. All right. Okay. That's silly. All right. So a few solutions. All right. Use a set for O of one and unordered set for O of one lookups for each value X of the input array A, then sort the input array B and return the first value seen if it exists. Plus fun bug because I did not return -1. I didn't read that, kind of skimmed it. So that cost me 5 minutes or whatever in a row contest, but yeah, whatever. Nothing's perfect. I most certainly am not perfect. So it's good enough, whatever. Got this done here pretty quick so I can hopefully get to Q4, which is the, let's do this sorted B. Actually, let's clean this up a little bit. All right, this works, I think. It's cool, right? It's in line. So that's seen, and then we can return. Oh, I don't think this works right. I tried this before. Does that work? I don't know. No. Yeah, this is okay. Yeah, I don't really need to refactor it too much, right? I mean, whatever. Good enough. Okay. Set is a unordered set. Integers. Set scene. Be all the values in A. Sort B. Oops. Okay, C++, JavaScript. I think this works. Yeah, it's cool. It's cool. Kotlin. To set, and then for x and p dot sorted. If scene contains x, return x, otherwise return 1. Okay. Rust is next. Rust. Vector of I32s. Use a hash set for what's been seen. Let's see, it goes hash set from, I don't know if that works or not. Let's see if we can just debug this guy real quick. Turn 0 at the end. Just for now. Scene from is not implemented. Hold on, let me look this up. Rest hash set from vector hash set by example victim.drain.collect. I see. A.drain. What is that? Did I read that right? Oh, it has a range thing. Hash set I32. Not borrow A is mutable. Okay. Let's make both A and B mutable. I need to make B mutable because I have to sort it. Turn one at the end here for X and B. If scene that contains X, turn X. Looks good. Big money, no whammies. Yay. Okay, there we go. Nothing too fancy, right? Use an unordered set for O1 lookups of each value X of the input array A, then sort the input array B, and return the first value seen if it exists, right? Nothing too fancy. Okay, 1 hour, 21 minutes left in the contest for Q2. All right. 1 hour, 21. Is it 21 minutes? Yeah. 1 hour, 21 minutes. Here we go. Transform this one to that one. So plus or minus K for each value. So sort it and then plus or minus K it. Does that make sense? Let's grab these and play around with it a little bit. Oops. Okay, so grab this guy. Grab this guy. Oops, I want to just whatever. Okay, here k equals 3. Okay, so if we sort these values, and it's 1, 3, 4, 4, 1, 3, oops, 1, 1, 3, 7. 10 to the 9th is huge. Does that work? 1, 3, 4, 4, 1, 3 equals 2, j equals 1. Okay, so plus 3. What? After applying this operation, oh, it's like a teeter totter. I see. Okay, one goes up while the other one goes down. I see. Okay. Oops. All right. I see. Okay, that makes sense. One goes up while the other one goes down. Operations for that. Use an unordered map. There has to be some balance though. Right, so the sum of this is 8, 11, 12. 12 as well. 12 and 12. Excuse me. Let's get back up there. Okay. And again, what's the sum of this one? 11, 18, 13. This one seems like it makes sense. Yeah, if the sum's not the same, they're not going to work out, right? Oops, A, B, and K. If the sum of A is not equal sum of B, we can immediately say, hey, yeah, this isn't going to work. Otherwise, there's a possibility it might work, right? If there's balance. And go up or down by K. So here there's a missing value. So we need to take a larger value and reduce it. All right, so n is 25. So we're looking for a near linear solution for acceptance. What is the algorithm like? What's the game plan then? Right, we can sort A and B. It's a 4-free primitive. Right, and then do perform a Grady solution linear scan. So we have 1, 3, 4, 4, 1, 1, 3, 7. So indices. Okay, so if it's cool, I mean, if they're equal, then it's cool, right? Otherwise, okay, these are not equal. So we have two choices, right? Two choices. Decrement larger value. Till it is equal to the smaller, right? Smaller value. That's choice one. Other choice two is to the opposite is increment a smaller value till it is equal to the larger value. How would I know which one I want to do? So there has to be balance, right? Balance is needed. All right, so plus k and then minus k. Hmm. Oh, that means like we should always, right? I think, is it safe then to always increment the smaller value? I think so. We have 2 pointers. Like the leftmost and the rightmost should go up and down by the same amount, right? Okay, right. So we have I going this way, J going that way with 2 pointers. And then you balance it out. Okay. So J be this guy. So increment this guy by 3. And then decrement this guy by 3. Okay, so this seems to be a min heap then. Not 2-pointer, because that won't run in time. But we can use 2 min heaps, right? I think so. Right, so continually extract minimums and maximums, right? We need maximums too, min heaps and 2 max heaps. That seems to make sense, right? 2 min heaps and 2 max heaps. Two min heaps, and then what would be the maximum value? Max heaps. I guess like I wonder like to avoid redundancy to the they're the same. Are they the same length? Yeah, they are the same length. Okay. Okay. Oh yeah, yeah. So n divided by 2 operations, right? Min A equals heap of phi. All right. This work. It's a max heap by default, isn't it? Min A, max A, copy of A, copy of A, phi. I think it's a max heap by default. So I'll have to take the negative value. Say 4, or while A, and heap pop max A. Pretty sure it's maximum. Oh, it's minimum by value. Okay, minimum by default. Okay. So this guy will be negative x for x is in A, x heap, min b max b is copy of b, and then ax, oops, and go x for x and b. Heapify those in place, min b by max b. Man, this is really ugly. I wonder, can we keep this more simple? Do we need to really continually? No, yeah, maybe a 2-pointer might be easier. I mean, I'm looking at this. This looks ugly, right? It's a bookie spell. All right, so we sort A and B. I think 2-pointer work. I think 2-pointer does work. Now that I think of this more. So this one. Maybe just one min heap. The maximum would sort of be on the right. So do you want the next minimum to match up with this guy? And this guy would be pushed back onto the min heap. Okay, let's try to simplify this, right? Remember, KISS, keep it super simple if and when we can. Okay, so how about 2 min heaps, right? And then sort A and B. So the right-hand side will be index J, maximums, the teeter-totter, and the mins will push back onto the heap. Okay, I think this works. Okay, so sort A and B. Okay, Q, and let's do P and Q. How about is make heap? I wonder Python. Make heap. I know there's heapify, but I wonder if there's another one I'm looking for. Heapify. Okay. Well, it is in place. Okay. P and Q is a copy of A and a copy of B, and then heapify let's do this. P. Let's do some white space. Q. By this guy. P. Oh wait, no, this one for them. P. Phi. P. And then P. Phi. Q. And then 4 range in evenly divided by 2. They're odd length. These are even length. They're odd lengths. Okay, which one's smaller? Well, if they're equal, then we're good, right? Oops. Otherwise, if they're not equal, then we'll bump up the smaller one to meet the larger one. Diff equals I guess we can hold on, diff equals absolute difference between A and B. If A is less than B, if B is less than A, I'll do something different. So if A is less than B, which is not the case here, B is less than A, but we would basically take the smaller one and increment it by a certain amount of number K to there, if possible, and then decrement the largest one by that amount. And this one is tough. This is only a 4-pointer, so I might be making this way more complicated than it needs to be. Is it really that complicated? Let's make them equal. Okay, so if A is less than B, we're going to increment A by, well, if diff is not a modulus, right? If diff mod K return -1, it has to be evenly divisible by K. Okay, so what we need is a factor of diff divided by K. Need to keep track of some index J. Just initially set to n-1. Decrement it as we go. So it has to be equal to that difference. So here, we're going to increment this guy. Increment this guy by 3. We're trying to change A into B. So for A to turn into B, since we already have a 3, what if we reduce, what if we remove same values first? Does that make our lives easier? All right, so we can do, is that 4, 4, 1 and 7. Right. 1 and 3 are common values. Ah, yes, yes. Remove same values first. Sort them, and then two pointer, right? Okay, yes, let's try that. Like, this is complicated, right? Okay, new game plan. New game plan. Remove redundant values first, then sort remain values, then two pointers. Right, reduce from the inside out. I will go this way, then J will go that way. I think that simplifies things, right? Okay, so let's do a map of A and B. A, B is counter A, counter B. For X in set A, have equals the maximum or the minimum of A sub X, B sub X. A sub X minus equals half, B sub X minus equals half, right? The minimum we have in common, we can reduce both by okay, and then we'll change A and B to be empty arrays. Or actually, let's do this here. A is equal to yeah, that works, right? A, B, or X and count and A dot items. A dot append the quantity and X count amount of times. I think we can just extend it, right? X times count. Do the same thing for B. Oops. Okay, so A and B is what's left over. 4, 4, and 7 looks good. Okay, A dot sort, B dot sort. Okay, and then I equals 0, J equals, let's see, so if they're not equal, right? If the length of A does not equal the length of B, then it's not possible. J equals length of A minus 1, while I is less than or equal to J, right? To account for the middle item. If they're equal, it's fine. If A sub I is equal to P sub J, oops. So then when they're not equal, I have to do something. I plus equals 1, J minus equals 1. Okay. Turn the cost at the end here. Oh wait, hold on. What am I doing here? Oh, is listening J. Okay, so delta 1. See, the left difference is A sub I minus B sub I. Right is A sub J minus B sub J. All right, so for this case, equals 4, 4. E equals 1, 7. They're sorted, right? I is this guy and J is that guy. So L is 4 minus 1, 3. And then right is 4 minus 7 is negative 3. Okay, so if L does not equal negative R, 1 times R, how about? Return negative 1, it's not possible, right? There's no balance. Otherwise, it's one operation where you add a certain amount to this one, subtract a certain amount to that one. Okay, how many Ks do we need to take then, right? How many operations do we need to take? And we need absolute value of L. If it's evenly divided by K, right? Or the value of L is not evenly divided by K. That's how many operations we need. Okay, I think that works, right? So one, no, it's two. Not. What does the order matter? Oh shit! Yeah, the order does matter. Decrement this. Increment that. Oops, okay. Oops. Okay, order matters. Okay, well that simplifies the problem then if order matters. Right? This must be transformed to one. So we can keep track of our remaining balance. This must equal that. This must equal this. This must equal that. Okay, now I get it. This makes a lot more sense. Okay. This makes a lot of sense, right? For why this is a 4-pointer, right? Simple. I guess, well, not simple, but more simple, right? Okay. Dang. Okay, well, let's do this. The count of operations is what we can return here at the end as long as it works. And then we need the balance of like how much we have left. Return count if what we have will be our balance. So it needs to balance out, right? So if we'll have negative, and let's just work through this. Through this with a more proper understanding of the problem statement, right? Note to self, right? Note to self, solve the actual problem, not something more generic and complex. Okay. A is this guy. B is this guy. Okay, so the difference here we have is 0 initially. For the ith value, what we have is, we'll do negative. This is the initial state. Hold on. After processing, the ith value of 0, we'll have -3. All right, so I'll transform this guy to 1 to match. This guy's a no op. Here we'll have this minus that. Oh, actually, it's positive 3. I have to do positive 3. It's positive 3. Okay, so then -6. -3 at this point. And then here, I'll have -3 and then +3, which is 0. Okay, and then at any point, if it's not evenly divisible by k, then we can return -1 immediately. Okay, so that makes a lot more sense. Okay, here we go. Okay, n is the length of A for I in range n. Difference is A sub I minus B sub I. If difference modulus k, if there's a remainder, return -1, you can't do it. Otherwise, we have plus equals the diff. If not have, else -1. Okay, I think that makes sense. No, oh, I need to increment the count, right? Okay, increment the count of operations. Okay, if let's see, count plus equals int diff is not equals 0. Right, as long as there is a difference, we have to do the swap. One operation, two. Oh no, there's 3 operations. Oh man, dang it. Okay, so logic's a bit off here. How many times? How do we count the operations then? I don't know if I've done the first one, minimum operations make rate equal number 1. Maybe I should do that and move on. I'm not really making too much progress here. I made this like super complicated. Okay, super complicated. Wait a minute, hold on. This doesn't seem right. And then, okay, now I thought it was super simple, but it's not quite that naive in that I still need to count the operations, right? This is not correct. This operations is 3, but I'm expecting 2. I wonder, you want to keep it super simple, so maybe keep track of the diffs. I'm about to pass on this one and come back. Uh, let's see. What if we keep track of our diffs for each? Smash that as 3, 0, -6, 3. take that positive 3, stick it on that negative 6. Take that positive 3, stick it on that negative 6. They should all be 0 in the end. Okay. So take the diffs, right? Which are these guys, and sort them. Negative 3, 0. Oh, wait, no, negative 6, negative 6, negative 3, 0, 3. Right, does this work? We can. Oops, 0, 3, and 3. Yeah, that does work. Okay, then 2-pointer. Okay. Holy cow. Okay, it's about to give up. I'm pretty sure this is it now. Okay. All right, so one operation, 2 operation. Okay. That makes sense. Okay. Okay, so diff equals difference between a sub I minus b sub I for I in the range. And let's do sorted. It's a safe move to sort it after you diff it. Okay. Right. And then do 2-pointer. Okay. So while it's not zeroed out, then you don't move. Okay. So I equals I j equals 0 and minus 1. Okay, so if any of these diffs is not divisible by k, okay, so if any x for x in diff x modulus k, then return -1 immediately. Right, it's not divisible by k, so that's not going to work. Otherwise, while I is less than j, then I can return count if all x is 0 for x in diff. Otherwise, it doesn't work. Right, so that handles the middle part. If a sub I is 0, then I'll increment I. Okay, otherwise, we need to take from I the largest amount of k in common. One of them needs to be negative, the other one needs to be positive. So if they're both positive, or if they're both negative, then we're going to have a problem. Or no, diff, oops, not diff. Diff, oops. Oh, wait, hold on. Let's do this. Actually, yeah, okay. Or the sum of diff, right? If it doesn't balance out, return -1. Okay, so we don't have to keep track of that. There has to be balance. So the sum of the differences has to equal 0. if I is 0, we move on. Otherwise, take the factor in common. Okay, so they're all divisible by k, and they balance out. Move on. Otherwise, take is the minimum of diff sub I divided by k, diff sub j divided by k. All right, we can take 1 in this case. Count plus equals take, and then diff sub I plus equals take, diff sub j minus equals take. If not diff sub j, we'll also decrement j. So, okay, right? Get some more coffee. Holy cow, it's hard to too. Okie dokie. Music going, coffee on. Negative key. So guess how many operations of k we can do, right? Be 0. Okay, right. Let's do this. Move forward from inside out. I think we can simplify this since we took care of it up here. And move forward as we go. So here, when I is this guy and J is this guy, we can take one. That counts one. So after we take one, this guy plus equals take times k, right? So it's 3 minus equals take times 3, right? So like this, take equals 1, count equals 2, we take another one, right? And then 0 and 0. This guy's zeroed out. This guy's zeroed out, and then I and J are equal to the same value here. Okay, I think that works, right? Let's see what happens. 2 looks good. Okay, -1 for the other y. Looks good. Anything I might be missing? I don't know. Let's see what happens. Big, oh, division by 0. Uh-oh. Corner case. Oops. Okay. Oops. Missed corner case. Okay, 0. Did not divide by 0. Okay, so if not k, then return sorted A equals sorted B. Okay, try this input 2. True. Oh. 0 if that, else -1. If there's 0 changes needed. Okay. That looks good. Big money, no whammies. Oh, wrong answers. -1. What? Oh, wait. Oh, I can't change them, right? I cannot change. Okay. A is equal to B. Okay. Oops. Yeah, the contest doesn't tell you what the expected answer is, right? Until you actually, but does it? I don't know. Okay, I didn't look. Okay. A is equal to B. Okay. Yay! Okay. Better late than never. 26 minutes left. Holy cow. Okay, so that took a long time. Okay, so we have 0 hours and 26 minutes remaining. So this one took 56 minutes. That's right, or 55 minutes. About 55 minutes. Ugh. I have a lot of room for improvement to be a competitor. But I worked through it, right? So it wasn't super straightforward, right? Initially, I was thinking, okay, what do we got here? We can move stuff around, which is not correct, right? So moving things around, we could get away with just one, which is more than, all right, it's less than the optimal solution, right? So learning experience, solve the actual problem, right? Order matters. This is important. Order matters. It makes it quite a bit more simple. Problem. Okay, and watch out for the corner case. All right. Yeah. Well, it is what it is. Okay. Work through it, stuck with it, says cool, right? This is awesome. I think this is a win. I'll count this as a win. I never gave up. Nor did I surrender. All right, so get the differences, sort them. Make sure they're all divisible by k and that they're balanced. Let's see what this dude did. This guy's pretty smart. Oh, no way. Really? This is way easier. They're not equal. How many increments you need? How many decrements you need? Mm. Yeah, it made it way simpler. This dude doesn't really participate in contests. I don't think he does. And all right, whatever. Surprisingly, seems to always have the same code of other people. Ups and downs, makes sense. Ups and downs for the balance. Most of the top voted solutions are junk, but I might as well look at a couple. Okay. Incrementing and decrementing makes sense. Like this is junk. This dude's solution is good. I'll vote him. Oops. Upvote coach. Super simple. Simplicity is intelligent. Complexity most certainly is not intelligent. Right? This is a whole lot of complexity that I originally had. That is not terribly too intelligent. All right, so I did the 2 pointers, I did the diffs, and what we can take. It's not too bad. His increments and decrements are way easier though. Have I'm not really even using. To count. What is this? Okay. Remember KSS, keep it super simple based on what coach did. Increment and decrement, and then return the amount of increments if increments equals decrements, right? So for let's just zip them. For A, B, and zip A, B. Increment and decrement. Okay. Increment, decrement, return increment if increment is equal to decrement, otherwise -1 if it's not possible. Okay, so if -a if either of them are not divisible by k, f equals a minus b, if not diff, continue. We'll refactor this code maybe a little bit. Okay, so if a diff is less than 0, we have to increment it. Increment one if diff exceeds 0. The difference is not divisible by k, then we'll want to return -1 immediately. If diff modulus k, return -1, right? It's not evenly divisible by k. How many k's do we want to take? How many increments is what we take, right? Take equals absolute value difference divided by k. Right, how many k's you take? Does that work? If k is 0, turn -1. Yeah, so that works. Div. We don't need this. Right. Simplify the code. Oh no, that does not work. Okay. There's not a div. Take. Really? 0. Oh. Okay, so if there's a difference and okay. If there is a difference and we can't go up or down by k, then we're turning -1. Otherwise, there's a difference and it's not evenly divisible by k. Okay, so that makes sense. Okay. All right, okay. Well, doesn't work. Let's do this. If k is 0, then we'll just return a is equal to b, right? That keeps things super simple. Oops. 0 if y is negative 1. Oops. All right, so that simplifies things. Diff. Like, yeah, I made this super complicated. This will be the last one I do. I'm gonna take my kids to the bus stop here. And yeah, we'll save Q3 and Q4 for later when I'm fresh. Q2 took a whole bunch out of me. I made it way too complicated. Complexity is not intelligent. That's cool though. I'm really glad. I'm really thankful for Coach. He's helped make me a better programmer. Perform a linear scan of each value A, B of the input arrays, A, B correspondingly. If any difference is not evenly divisible by k, right? Note for the corner case, when k is equal to 0, then we return 0 if and only if a is equal to b. The y is -1. Immediately return -1. The y's take equals diff divided by k. You take the take take the difference divided by k. And so diff Otherwise, we take the absolute difference divided by k, right? Diff divided by k. Track the, all right, and accumulate increments and decrements. That we take. So if the increments right, if the increments and decrements not equal, then there, right, then a return -1. It's not balanced. Right, not balanced. I think that makes sense, right? Perform a linear scan of each value A and B of the input arrays A and B correspondingly. If any difference, diff equals A minus B, is not evenly divisible by K, immediately return -1. Otherwise, we take the absolute difference divided by K, diff divided by K, and accumulate the increments and decrements of what we take. If the increments and decrements are not equal, then return -1, not a balanced solution, right? One has to go up by K, the other one has to go down by K. And for the current case of K equals 0, return 0 if and only if A is equal to B, otherwise -1. That looks good. Okay, let's do this in the languages here real quick, and then I'm gonna go to the bus stop. Take my kids to school. Okay. Getting some weird feedback from my headbuds. And yeah, because lecture goes online. Increment and decrement. It could be a long while. Decrement. All right. If not K, return A is equal to B. 0, otherwise -1. All right, and then more ith value. B sub I, B sub I, B sub I, minus B sub I. If turn -1 immediately, it's not even divisible by K. Otherwise, take equals the absolute value of difference divided by K. increment plus equals take if diff exceeds 0. Oops. 0 decrement diff is less than 0. All right, that looks good. It's cool. Good. Okay. To JavaScript. A, B, K, inc 0, decrement 0, turn decrement equals decrement. K, turn equal B, 0 plus -1, for let A B of low dash zip A B at diff equals A minus B if diff is not evenly divisible by K, return -1 immediately. Take equals the absolute value difference evenly divisible by K. Increment plus equals diff is seeds exceeds 0. Decrement diff is less than 0. We'll take whatever that is. Okay, that's good. Uh-oh, that's not right. -1 should be 0, right? May use low dash for deep equality. Low dash equal is equal deep value, right? Comparison is equal A B. Okay, that looks good. It's cool. Thank you, low dash. Okay, let's go, let's go, let's go. Come on. Kotlin. A B. Oops. If K is equal to 0, turn if A is equal to B, 0, otherwise -1, for A B and a zip B. Okay, let's do increment, decrement equals a pair 0 0. These longs. Return if increment is equal to decrement, return increment, otherwise -1. If is A minus B, if diff modulus K. I think we want to, actually, no, I don't know if that matters. I equal to 0, returning to 1 immediately, otherwise it's saying take is the difference divided by K, and I do want the absolute value here. Increment plus equals if diff exceeds 0, take increment. Diff is less than 0. Okay, looks good. Uh-oh. Unresolved reference K. Oh, I want uppercase. Come on. -1 is not correct. Comparison. Let's see. Kotlin int array deep comparison. Oh wait, compared to, right? Okay. A dot compared to, I think. compared to B. Does that work? Compared to Kotlin compare arrays equals content equals content deep equals content equals for deep comparison. What? Oh, oops. Big money, no whammies. Okay, that was good. Content equals. Okay, cool. All right, save the best for last. We got Rust, and then I'm gonna call it a day. What do we have? Oh, the contest already ended. Okay. I'll do Rust real quick and then just call it a day. Okay. A, B, BI equals spec 32. I, K. Let's mute ink, mute tech equals 0 on 0 on. If increment is equal to decrement at the end, then we'll return increments rise 1. Or A, B, and A dot zip B dot. See if this works. Right. Expected in pattern. Oops. Destructure this. Println is a macro. Okay, that looks good. Okay, so let diff equals this guy minus that guy. If diff modulus k does not equal 0, return immediately. Otherwise, increment let's suppose if exceeds 0, what we take, let take equals the diff divided by k. Otherwise 0. Decrement if diff is less than 0, we take otherwise 0. That looks good. Oops, I need to consider the case for k. If k is a 0, return if a is equal to b, 0, otherwise -1. Okay. Oh, I'll subtract that from that. Really? Dereference it. Strange. Take minus 64 as 64. Uh-oh. Absolute value. Oh wait, hold on. Yeah, absolute value. There we go. That was good. That's cool. This is weird. Do I really need this, or can I just do a minus b? Let's see. Oh, that works. Okay, that's a lot way easier. Okay, cool. Post this and call it a day. Come back to Upsolve Q2 and or Q3 and Q4. Okay. Looks good. Nothing too fancy. This. To ensure balance. Looks good. Okay, catch you all later.